Hello, this is Mr. Huber. In this video, I'm going to go through an answer key for the timed quiz on unit circle and special trig values. So we're going to see some reference angle stuff in here as well, like the first question. Reference angle, that's alpha equals 74 degrees, theta equals, and in this case, in quadrant 3, means we're going to take 180 plus the reference angle of 74 to get our theta of 254 degrees. And just a reminder, these questions might not appear in the same order you saw them because it randomizes the order, but these are all the same questions you would have had at some point on that quiz. All right, so number 2, I'm going to use cosine. This is negative 24 over 26 in quadrant 3. Just a quick sketch of that quadrant 3 means we're going to have some reference triangle out here in quadrant 3. And cosine is x over r. So it means our x 24, r 26. This would be a 12, 13, and then this would be a 5. So it's a 5, 12, 13, or you could set up 24 squared plus y squared equals 26 squared. X squared plus y squared equals r squared. And it's a 5, 12, 13, all multiples of 2. So this would be a side of 10, which this point then is negative 24 comma negative 10. We want to keep that in mind, right? That they're negatives because they're both in quadrant 3. Tangent is y over x. So in this case, the y value negative 10 over x value negative 24, and that would reduce to 5 over 12. And you could use the 5, 12, and 13 because when we expand the triangle and make it some scale factor, so if the ratios stay the same, right? It doesn't matter as long as that reference angle is the same, then the ratios are going to be the same. So you can use the 10 and 24, or you can use 5 and 12 and reduce to 5 and 12 there for your final answer, and it's positive. Tangent's positive in quadrant 3. All students take calculus, T, tangent positive in quadrant 3, so negative over negative gives us a positive final ratio for tangent. All right, number 3 says tangent is greater than 0. That means it's positive in quadrant 3 because we just talked about, all right? Y and x values are both negative in quadrant 3. So it's going to give a positive ratio for tangent. All right, now we move to number 4 here. Given a circle centered at the origin with a radius of 2.5, find sine 30. It does not matter what the radius is. We can use the unit circle to know this same ratio. So we have 30-degree reference angle here. Okay, if that's 1 half, because the short leg's half the hypotenuse, and then times the square root of 3, so 1 half times the square root of 3 is square root of 3 over 2. Sine is y over r, it's the y value, so sine would be 1 half. All right, and it doesn't matter if I make the radius 2.5, I could go through and write out ratios of using different lengths and measures there, as we saw in that last one, right, with the, well, not the last one, but the one with the 5, 12, 13 that was doubled. The ratio comes out the same, all right? So it doesn't matter what the radius is. When you put in your calculator sine 30, it's going to give you an answer without knowing what the radius is because it bases everything off a unit circle, radius 1. When the radius is anything else, it's going to come out to those same ratios, all right? And number 5, whenever the reference angle is the same, each trig ratio will be the same. That was the answers that would fill in those two blanks. That's kind of what we've been talking about. This is one of the keys to this entire section, one of the main concepts you've got to make sure you understand because this is the basis for what happens with the unit circle and with these trig values and building on it going forward. Okay, whenever the reference angle is the same, each trig ratio will be the same. All right, so whenever you have a 30-degree reference angle, for instance, each trig ratio for sine is going to be the same. Cosine is going to be the same. Tangent is going to be the same. All right. In number 6 here, it says what are the coordinates of the point where an angle of 480 degrees in standard position intercepts the unit circle? So first thing I would do is subtract 360 from this and know that really we're talking about 120 degrees. All right, if I drew out 360 plus another 120, this would be theta 480 degrees. Okay, this part right here is 120 degrees in red. Okay, so this means we are at the point here with a reference triangle where the reference angle is 60 degrees. Okay, so we're looking for that point, the coordinates for that point. All right, and so we're going to have an x value of 1/2 and a y value of square root of 3 over 2. It's a 30, 60, 90 triangle. Okay, the long leg is the y value here. That's a square root of 3 over 2 across from the 60 degrees. Okay, and then we want to make sure we have the right coordinates, plus or minus, depending on what quadrant we're in. Okay, those would be the ratios. Again, anytime there's a 60-degree reference angle, your ratio for x, which is cosine, is 1/2, and y, which is sine, is square root of 3 over 2. And then depending on what quadrant we're in, we might have positives or negatives. So in quadrant 2, we have a negative x and a positive y. So your answer would be negative 1/2 comma square root of 3 over 2. All right. Going to number 7 here. All right, and for these, I'm going to draw, and I've been talking a little bit about this, and I've talked about it a bunch on some of the lessons leading up to this, but really we only need at most 3 triangles to answer every question about these special trig values. So I'm going to draw out here a 30, 60, 90 triangle. There's 30. Okay, we talked about this a little bit in one of the other problems. And this would be square root of 3 over 2. I didn't give myself much room to write that down there. So this side would be square root of 3 over 2. All right, radius is 1 in the unit circle, short leg half that, long leg times the square root of 3. And if we draw a 45, 45, 90 triangle, so this is 45, 45, 90, radius of 1, then we take 1 divided by the square root of 2. All right, the short leg, the leg in this case, they're both the same, is divided by the square root of 2. So 1 divided by the square root of 2, and then we need to rationalize that. So we'd multiply by root 2 over root 2, and we'd have square root of 2 over 2. So in a 45, 45, 90, we have the 2 legs both as square root of 2 over 2. And if you want to draw a 60-degree reference angle, it's just the 30, 60, 90 we already drew, okay, where the short leg and long leg are flipped, which one's the x and which one's the y. So the short leg is 1/2, and the long leg is square root of 3 over 2. All right, so now we could use those. The exact trig value for cosine 330 degrees. That's a reference angle of 30 degrees. That's in quadrant 4. Reference angle of 30 degrees. Okay, that goes back to that first triangle I drew. Reference angle 30 degrees. Cosine's the x value, so that's square root of 3 over 2. In quadrant 4, cosine's positive, so square root of 3 over 2 is my final answer. Negative 270 degrees. So tangent negative 270. That's the same thing as positive 90 degrees. That's the same as a positive 90 degrees, okay? If I go negative 270, okay, that's the same as positive 90. Okay, so I'm talking about this point right here. All right, that point doesn't use one of those special triangles. That's the point 0, 1. 0, 1. Tangent is y over x, so 1 over 0, that's undefined. Undefined. All right, can't divide by 0. The exact trig value of tangent 570 degrees. So I subtract 360, I get 210. So this is the same as saying theta is 210 degrees, okay? Which means we have a reference angle of 30 degrees, and we're in quadrant 3, okay? Reference angle 30 degrees, tangent's y over x, so the y is 1/2, the x is square root of 3 over 2. That's 1/2 times 2 over the square root of 3. Okay, multiply by the reciprocal. So when you divide by a fraction, same as multiplying by its reciprocal. That's 1 over the square root of 3. And then I need to rationalize that. And so my final answer will be square root of 3 over 3. I'm in quadrant 3 where tangent's positive. So square root of 3 over 3 would be my final answer. All right, then we can go to the next problem here, which is negative 135 degrees. So negative 135 is right out here with a reference angle of 45 degrees in quadrant 3. So the reference angle is 45 degrees, and we're in quadrant 3. All right, so reference angle 45. So if I wanted to go back up to that triangle I drew already, right, I don't need to keep redrawing these. I got the 45, 45, 90. My sides, x and y, are both square root of 2 over 2. So sine is y over r, or just the y value, okay? Because it'd be square root of 2, not square root of 3, let's change that, square root of 2 over 2 over 1, right? That's y over r. The r is 1, so that's why we can know that the sine value is really just the y value, because it's always over 1 in the unit circle. So it's square root of 2 over 2. All right? And then we've got to make sure we know what quadrant we're in. So the square root of 2 over 2 came from the reference angle being 45. Quadrant 3, sine is negative, so it would be negative square root of 2 over 2. Next one, 510, negative 510 degrees. So if I do 510 minus 360, okay, that's 150 degrees. So this is the same thing as negative 150 degrees. Negative 150, okay, would be right out here. That's negative 150 degrees. And we'd have a reference angle of 30 degrees. Okay, reference angle of 30 degrees, that's a y value for sine. The y value is 1/2, so that's 1/2. And we're in quadrant 3, so I'd need a negative 1/2. Right, negative 1/2 for sine of negative 510 degrees. And we've got one more to talk about here. All right, y is the ratio for sine always equal to the y coordinate of the point where the angle intercepts the unit circle. Talk about those some of the problems I just did. It's because you're always putting it over 1. R is 1 in the unit circle. So y over r is just y over 1, which is equal to y. When you put something over 1, it's just equal to itself. All right, so that's important to know. The cosine is always the x value of the point on the unit circle. Sine is always the y value because you're putting them over r, which is 1. Tangent's the one where there's a little more work to do, as we saw. All right, so that walks through the different problems and answers for those. Hopefully that helped if there was any areas or problems you had difficulty with. If you're still unsure about anything, you can rewatch or do what you need with this video and follow up with me if there's still concerns you have, questions you have about any of the problems or answers, so you can make sure you're understanding the material to the best of your ability.